Okay, this is our first real day of calculus. What we're going to be doing is looking at things that you can't get by pure algebra that we really need. For example, the first example that everyone looks at on their first real day of calculus is the function sin x over x. Now in an algebra class, if you had an x in the bottom where you couldn't plug in 0, that always meant an asymptote. But you can see from this graph, there's no asymptote here. It actually looks continuous. If I actually try to plug in the point, and I can't seem to quite get this here. Oh, there it is, right? You can see when you plug in 0, the graph is undefined. But if I move just a little bit to the left, you can see the height is 1, and just to the right, the height is 1. And so what happens is, in calculus, we want that dot so that we can make the function continuous, and there's no way to use pure algebra to find it. So we give the height of the whole a name, and we call that height of the whole on a function, when x equals a, the limit of f of x. Now hopefully I'm going to move over to this, and I just want to see some notation. The notation is this. I write down the limit as x approaches 0 of the sin x over x equals 1. But that's not the way I'm going to read it. The way I'm going to read it is, there's a hole on the graph of sin x over x at x equals 0, and the height of the hole is 1. In general, we should be able to do this for any function. I can do this bit by bit by reading this, the limit as x approaches a of f of x equals L. But really what I'm thinking is, there's a graph of f of x, there's a hole on the graph, and the height of the hole when x equals a is L. Now there's a slight alternate description that's really kind of cool. The idea is, if you can't see the hole and you still want to find that dot, what you do is that you put a vertical wall in at x equals a, and then you walk the fingers, can't do this without getting light, of your right hand, and you walk the fingers of your left hand so they hit each other at the wall at that height, and the height your fingers hit each other we call the limit. Well, there's two descriptions. If you can see the hole, it's just the height of the hole. If you can't see the hole, you have to walk the fingers of your right hand, the fingers of your left hand, and have them crunch into each other. The height that they crunch into each other, we call the limit. For those of you who want to be high school teachers, you can actually buy giant fingers that you can work with.